Hello everyone. Today we will be understanding a binary symmetric channel and how the concept of probability can be applied in order to understand maybe the probability of correct reception or maybe the posterior probability or probability of erroneous reception. Okay, as you see in the question, what we are considering is a discrete memoryless channel to transmit binary data. When I say binary data, as of now, let us consider we are transmitting 0 and 1. Okay. So this is at the reception side. We are supposed to receive 0 and 1. But due to certain unavoidable noise, what happens though we have sent 0, a 1 may be received at the receiver side. Okay. Similar way, though we have sent a 1, a 0 might be received at the receiver side. So now just for ease of learning, what I will do, I'll give a label A for the transmitter side and a label B for the receiver side. Okay. Before doing any of these calculation, first we need to know at least the priori probabilities because these are at our hand. Priori probabilities are nothing but the probability of sending a 0 and probability of sending a 1. Okay. So let the probability of sending 0 be small p naught and probability of sending a 1 be p1. Okay. So please make a note when I write probability of, I have written a capital P, and this side when I have written a constant, I have written small p naught. Okay. These are not complementary. Please understand that. First, I understood the priori probabilities, and next I need to have some knowledge about conditional probability. Okay. So what is given in the question? We are supposed to find posterior probability. What do you mean by posterior probability? First, let me write the equation. Okay. So posterior probability is probability of a 1 is sent when a 1 is received. Also, a probability of a 0 is sent when a 0 is being received. These are posterior probabilities. These are what I have to find. Okay, let me focus only on this. But something is missing. So that what is that? I need to find P of A0 by B0, what P of A1 by B1. Okay, I already know P of A not P of A1. So I should know one more parameter that may be either probability of erroneous reception or I should know about probability of correct reception. Okay. So as of now, we shall assume any of these. Again, these are complementary. Understand. In case if I know P of erroneous reception as 0.4, 1 minus 0.4 will be probability of correct reception. Okay. So now I will assume one of these. So assume erroneous reception means in case if I write B0, probability of 0 being received when A was sent. Let this or P of B1 by A0. Let this be small p. In case erroneous reception is small p, that means what? P of B1 by A1 or P of B0 by A0. This is equal to 1 minus P. Okay, this is what we have assumed now. Now let us start with the posterior probability. Let me find only for the first one. So P of A1 by B1. Understand this is conditional probability. I will be applying the Bayes rule. First, let me consider in this manner. P of A1 intersection B1 divided by P of B1. This is equal to P of P1 by A1 into P of A1. Okay, that's how you have to remember, divided by P of P1. We have P of B1 by A1, that is 1 minus P. We already have P of A1. This is the priori probability, P1, small P1. We need to find P of B1. Okay. In order to find P of B1, we will be applying something called total probability expression. Question you might ask me. Why total probability? Why not directly with one parameter? Understand? Reception of B1, this is maybe due to A naught, maybe due to A1. Okay. In case if there is an error, it might be due to A naught also. Correct? So that's why we go for total probability. So that is given by P of B1 by A naught into P of A naught plus P of B1 by A1 into P of A1. Okay, this is the total probability expression. What is P of B1 by A naught? This is erroneous, correct? Erroneous reception we have given as small p. P of A naught we have given as P naught plus P of B1 by A1. It was complementary to erroneous reception. So it is 1 minus P. P of A1 is P1. This is P of B1. So now let me go back to this expression. Let me give it as 1. So P of A1 by B1 is equals to P of B1 by A1. That is nothing but 1 minus P into P of A1 is nothing but P1 divided by P of B1, which is nothing but P naught plus 1 minus P into P1. Okay. So this is one of the posterior probabilities. Probability of a 1 was sent when a 1 was received at the receiver side. That probability we have found. Similar way, you can find P of A naught by B naught. So P of A naught by B naught will be similar expression I will write here. P of B naught by A naught into P of, sorry, P of this one should be P of A naught divided by P of P naught. P of B1 was P naught plus 1 minus P into P1, and P of B naught, I guess, only change will be here. P of B naught by P of B naught by A1, P of A1, P of B1 by B naught by A naught, P of A naught. This thing remains same. Only here the equation will change. Let me write that. Give me a moment. So this equation changes to 1 minus P into P naught, P1 plus 1 minus P into P naught. Okay. This is one more posterior probability expression. Understand? Okay. This is how you can apply probability concept to binary symmetric channel. Now you understand one more thing. So in case, instead of posterior probability, the question was to find probability of correct reception. Okay. So what in case the question was to find probability of correct reception, what will you have to find? P of B1 by A1 and P of B naught by A naught. Understand? Okay. In order to find P of B1 by A1, anyhow, you need to have knowledge about priori probabilities. Priori probabilities, and you need to have information about posterior probabilities. Okay. Here, the assumption was made by considering probability of erroneous reception. But in case if correct reception you have to find, then in the question they should give you posterior probability. Hope you all understood the concept. So that's it for the day. Thank you.